And welcome to this section on securing your cloud. So today I want to talk to you about a couple of different things. The agenda for today kind of looks something like this. First of all, the standard disclaimer, please don't steal anything. Please, leave everything the way it was when you got in. But yeah, I'll spend some time introducing the product because I suspect for a lot of people in the room, this is the first time they're actually seeing this product. I want to kind of give you at a high level a view of what it is we're trying to achieve with the vCloud Director product line. And then I'm going to spend some time talking about some of the security features that we've built into the product. So we're going to talk about how we do identity and access, what are some of the different features that we have in that area, kind of how we support multi-tenancy, what the networking looks like from a security perspective. And then at the end, we're going to talk about secure deployment a little bit. We've actually spent a lot of time thinking about how we'll actually deploy a product like this in the real world, how we're actually going to set it up, either a service provider or an internal cloud. And so I want to share some of those experiences with you because we've actually found there are a lot of small gotchas about how this product works and the things that you need to set up right to actually take advantage of this product. So with that, let's go ahead and get started. The first kind of slide over here is just a build-up to show where this actually sits in our stack with reference to other VMware technologies. So most of the people in the room should be familiar with vSphere. This is the, what we call the substrate or the cloud OS that actually provides the hypervisor, vCenter, and other management functionality that forms kind of the core of what this product builds on top of. Alongside that, we have View, which is our VDI desktop computing environment. And we layer what the product that we build, which is the vCloud Director product line, sort of gets layered on top of that. And what you'll see over here is this is the middleware layer that provides a common sort of abstraction and infrastructure to actually manage a public or a private cloud. On top of this, you'll see other technologies kind of get layered on. So the SpringSource acquisition is an example of a technology that will probably get layered on top of our layer and will be able to provide sort of a platform as a service cloud to consumers that are actually looking for a programmatic environment. And then on top of that, we suspect that core IT services such as Zimbra, mail, exchange, print servers, so on and so forth, will be built using that and will lie on top of that. And then the other kind of thing I wanted to point out was basically the fact that we suspect that the approach that VMware as a company is taking is what I would term as the hybrid cloud approach. We are trying to build a cloud that can be deployed in both the private world and the public world, and we have a common API that lets you bridge across the two. In addition, there are going to be, sort of commodity or like extremely public cloud providers, such as exemplified by the EC2 model. So this particular picture is just a few basics about the product, how it works, and what are sort of some of the things that you need to be aware of about the product. So the core idea of the product is to take resources that are backed by vSphere and expose them to an end user through a GUI and an API that end users can then use to actually provision VMs or vApps on their own. So how do we actually go and do something like this? At the lowest level, what you'll see is a set of ESX pods or clusters that are being controlled by vCenter. And you'll see that there's more than one of these that we can connect up to the vCloud Director. The VCD cell over there is basically one instance of the vCloud Director code running. And on the next slide, we'll kind of get into how you can use those to scale a VCD instance out. And so one important thing to note, we can work across multiple vCenters. In version 1 of the product, we support up to 25 different vCenters simultaneously. Now, this is what I was talking about, the scaling. The idea is that this is so each cell is basically a stateless distributed system. And the idea is that you can have as many of these as you need to scale up to the number of users that you actually support. These cells are stateless, so what that means is if one cell dies, whatever functions were being run on that cell will be picked up by another cell that will detect the failure and fail over all those sessions and so on. So if, for example, you had end users who were talking to a particular cell and that cell died, the end user would just see the traffic get routed over to another cell and would see no disruption in service. Now, that's kind of the back end, and the way users actually access this is through a web portal or through the API. The vCloud API is sort of the unit of heterogeneity in our product. So for example, if you had two different clouds that wanted to talk to each other, the way they would do so is by using the API. And in addition to that, at some point in the future, we will see a vSphere client plugin that allows you to transfer workloads from vSphere directly to a VCD-powered cloud. So this particular diagram is kind of the scale-out architecture of the product. There's just a couple of things that I wanted to call out over here. The layer below is basically the vSphere layer, or the substrate as I termed it. And this is where you can see sort of that horizontal scale-out that we were talking about. Anytime you kind of see you have a lot of users and you're kind of using up the capacity at your at the cells, you can simply add a new cell, stick it behind the load balancer, and basically you've turned on more capacity for end users. So another thing that I kind of wanted to mention, and this will become a little clearer actually probably on the next slide as we kind of go into the model of like how these things are structured. But when a customer signs up, now I want to make it clear that a customer could be in the private cloud space. A customer would probably be like the finance organization or the marketing organization or the sales organization. In the public cloud space, that could potentially be like different companies that sign up for services, like Coke and Pepsi being two of the examples that we use internally. So when an organization actually signs up for a service, they actually get to decide what the model is that they're going to use. So we support 3 different models in this product. We call them the allocation model, the reservation model, and the pay-as-you-go model. And what it really comes down to is who controls the overcommit, who actually controls the overcommit who controls the overcommit of those resources at the back end. So if the service provider decides that he is going to overcommit those resources, and what that means is that you assign an end user about 10 gigs of space, but you only back that with, say, 5 gigs of space, that is actually something that we call, that in our model is called the allocation pool model. Now, the other model is the reservation pool model, which is basically just the allocation pool, but with 100% reservation. So that would mean that basically you give the end user the amount of space that they actually requested. And then lastly, we have the pay-per-VApp model, or the pay-as-you-go model, which is basically what has been kind of popularized by the EC2 sort of public cloud services. And what you see over there is basically you get charged by the size of the VM or the number of resources that you actually consume. So those are kind of some of the key things about the product to keep in mind. I kind of want to set the stage in terms of having everybody understand what the product does at a high level before we actually go into the security features of the product itself. So, as I kind of mentioned, there are 4 things that I want to talk about. One of them is how we do authentication and authorization, or identity and access. Then we'll talk about the network security aspect, which is mainly centered around the vShield Edge appliance. And I'll spend some time talking about the different kinds of networks that we support in the product and how you can use those. Then we'll talk about some of the defense in depth features that we've built into the product. So, one of the major concerns when you talk to customers is how do they ensure a certain quality of service for their end users? And so we've built in a lot of features into the product around how can you ensure that one particular user cannot impact what another user does on the cloud. And then lastly, we'll talk about multi-tenancy and how you can actually set up the product so that 2 different organizations can share the infrastructure without worrying that either of them will be able to see somebody else's data or be able to interfere with the execution of a VM. So the vCloud Director product uses something called role-based access control. What we mean by that is that we've defined in our product several different rights, and we've defined certain roles that are basically a collection of those rights. Now what ends up happening is that the system ships with about 4 different built-in roles, and I'll show you on the next slide what those roles actually are, who they map to, and what permissions they give you by default. In addition, you can create custom roles. So if, for example, you had users in your company or in your enterprise that you wanted to give only a subset of access to, you can go ahead and create a custom role and give them that level of access. In this particular version of the product, it requires the system administrators and the org administrators to sort of work in concert with each other to decide who gets what level of access. So these are the built-in roles that actually ship with the product. And what you will see is basically we have at the top is what I call the system administrator or root. That should not be service director, by the way. That should be vCloud director. These are the users who are actually, they're kind of the sysadmins of the entire system, right? They own the entire system. They create the different organizations. They give access to the users in the different organizations. They are the ones who actually go ahead and create the organization administrator when they actually create that instance for the first time. It's important to note that in this version of the product, you cannot control access from the system administrators. They have complete access to the system. They can actually touch all the different parts of the system, and that role is atomic. We do not allow you to split it in this particular version of the product. Those are features that we're working on, and in future releases, you will see that we're going to introduce separation of duties for that particular admin as well. Now, the organization administrator is sort of like the system administrator, but within their own little sandbox. So in our product, the way the product works is that different organizations sign up for service, and the system administrator goes ahead and allocates resources to that particular organization. So the organization admin will see things like, he will see the settings that are particular to his particular organization. So those include things like what is the identity backend that is being used to authenticate users? What are the policies around, what are the policies for email, for like sending notifications out to users, and so on and so forth for within the particular organization. They also do things like create the catalog for a particular organization. So they own the service catalog for their own organization, controls who has a view into that catalog, what they can do with those templates, and those kind of access rules. The VApp owner is basically, so when you create a service catalog, we populate a service catalog with virtual appliances or VApps. A virtual appliance is basically a collection of VMs that work together to deliver some function. So an example of a virtual appliance might be like, say, a SharePoint server that consists of 3 different VMs that together form the SharePoint deployment that you can kind of power on and off. When you actually create the service catalog, you can decide who actually has the ability to edit that particular template, and that is the user that we call a VApp owner. And then finally, not on the slide, is we have this concept of an end user, which is basically the person that can take a VApp and power it on or power it off, or in our lingo, deploy it or undeploy it. So all that particular user will be able to do is see the list of VApps that they have access to and power them on or off. There is no other operation that they will be able to take. Now, additionally, you can go ahead and define any custom roles from all the rights in the system. As you can see on this slide, what we've done is we've looked at all the different operations that are possible in the system, and we've defined rights for them. We have about 50 different rights that are defined in the system, and you can go ahead and create a custom role for any of these from any of these rights. This is actually, having seen a few of the different systems out there, most systems out there do not actually provide this level of granularity of access. So this is, one of the differentiating features we believe in the product, and is kind of squarely, this puts us squarely into the enterprise space where we believe these features are kind of essential for setting up private clouds. So the next thing I want to talk about on this kind of theme is what are the different mechanisms that we support from an identity and access perspective. So we actually have 3 different ways of storing user identity and passwords in our system. The most simplest model is basically you provide us the username and password, and we store it in our backend database. We do appropriately hash it and salt it before we store it there, but this is probably the least secure method that we have, and the one that we would probably recommend the least. It also does create an identity management issue. So once you do this, you're kind of responsible for the management of the identity in the backend, and you kind of have to ensure that you have the right policies for removing users when they leave, making sure that user profiles stay current, password complexity, and so on and so forth. Those are all sort of maintained by the user and becomes the responsibility of the user. The way we actually recommend you set up your system is by using an LDAP identity provider. So OpenLDAP, AD, whichever one you prefer, we would support anything that speaks LDAP. Even in that, you have 2 different options. So you can set up one LDAP instance for the entire cloud, or you can set up an LDAP instance per organization. So in the case that you set up an LDAP instance for the entire cloud, that would kind of be common in, I believe, like the private cloud space, where basically it's one enterprise, you have one kind of LDAP backend, and you want to pull all the identities from that particular backend. You can do group mappings, so you can take particular groups and map them to certain roles. So this frees you up from the problem of going and having to add a user every time a new user kind of joins the enterprise. And you can also use that backend LDAP directory server as a place where you specify your password policy and kind of your password complexity rules and all those sort of things that you probably want to take care of in an identity management system. Again, you can also set up the LDAP on a per organization basis, and that is where that is the direction that we think you will see as being common in the public cloud space. Towards the end of the deck, I'm going to talk about secure deployment. And one of the things that I'll talk about is how do you actually set up an AD server or an LDAP server so that it is accessible by the cloud, but is still secure, because you probably do not want to stick your LDAP server out in DMZ. So now let's talk about networking. Before we actually go into the details of the vShield Edge device and what it does, it's kind of useful to understand how networking works in the vCloud Director space. So we have three different layers of networking. We have what we call a provider network or an external network. We have an organization network and a vApp network. A lot of people get confused by the complexity of the networking over here. I think a very simple way to think about it is that you have a network that is provided by the cloud operator to an organization. Think of that as the external network or the provider network. This is set up by the operator or the provider. The second layer of networking are the networks that are internal to the organization themselves. So, once the organization has like a public backbone, it probably still needs a way to segment all the different applications within its network. And those are basically what we call the organization networks. Now, some of these networks could be within a virtual appliance themselves. So the virtual appliance is stored in the OVF or the open virtualization format and has a notion of networks. So you can actually create an appliance that has three different VMs that are connected to a common network, and you can store that as part of the configuration of the virtual appliance itself. We call that the vApp network, and this is set up by users. So this would be created by either a vApp owner or an end user in kind of that role, in the role hierarchy that I specified earlier. Now, one thing that's worth noting is that at each layer, so a vApp network talks to an org network or to an external network. An org network talks to an external network. When you set up these connections, you have two options. You can either directly connect those networks, and so directly connecting those networks would be something like using a crossover switch and just connecting those two networks together, right? Or you can connect them through the vShield Edge device, and that's where some of the security comes in. So the vShield Edge device is basically a virtual appliance. It's a virtual router that provides 4 distinct pieces of functionality in this particular release of the product. So you can set up firewall rules with stateful packet inspection. You can set up DHCP, and you can set up NAT. So basically what you can do is you can control what traffic comes in at every layer. So what traffic is allowed from an external network to an organization network. What traffic is allowed from an organization network to a vApp. At each layer, you can set up those rules. If you actually had cascading devices, then you'd end up with like the union of all those rules is the traffic that you'll see at your VM. You can also use it to do network address translation. So what you can see over there is, if you actually wanted to limit the IP addresses from leaking out to the external world, you can set up NAT rules at the edge that would control what IP addresses actually are allowed to talk to the outside world. There's a lot of kind of different advantages to doing this. So firstly, by having a virtual appliance, what we're doing is taking what is essentially being a service that is provided by hardware and turning it into a virtualized service. So you will see a lot of investments over time from virtualized networking, which will make it very easy to provision networks on the fly, provision networking services on the fly, reconfigure your firewalls without actually having to go and touch any hardware appliances, all from one kind of single pane of glass from the vCloud Director GUI. We deploy one edge per organization automatically. So every organization that is deployed gets its own edge device, and you can configure the firewall rules for that particular device. Additionally, every time you connect those two networks together, you can choose to deploy an edge at the boundary of those two connections and configure it with whatever rules you'd like. The edge appliance is controlled. It does have a REST interface to it. However, if you're using the vCloud Director product, you can actually set up all these services using our GUI, and we take care of provisioning the underlying device. So the only time you will actually interact with the edge device is at the point where you actually install the product and have to provide a license key. After that, that all kind of gets subsumed by our UI and kind of our user experience. There are certain services that the edge device is capable of that are not exposed through our UI. Two primary ones that I'll call out is in this particular release of the edge product, you can set up secure IPsec VPN tunnels. To access that piece of functionality, you actually have to go into the VI client and configure it over there. Question?
You have more than one edge per organization?
You can have more than one. So you'll have at least one edge per organization, which we deploy automatically. And then additionally, every time you deploy a network, you can choose to deploy an edge with that network. Yeah. So I mean, this is actually a pretty small group. So I think if you guys have any questions, please feel free to put your hands up. What I'll do is I'll wait for the slide to get over, and then I'll kind of call on questions. So now we're going to talk about some of the defense in depth features that we've built into this product. So one of the concerns that we have when we go and deploy a kind of relatively or a medium-sized cloud is what happens when you have one particular user who's doing a lot of operations and is kind of denying other users the ability to use the cloud. So the way we actually worked against this problem is that we went through our system and chronicled what are all the different operations we do, and we defined what we call in quotes like the heavy operations. So a heavy operation is an operation where the user performs one action, but that results in kind of either a long tail in terms of the operation at the back end, or in a consumption of a significant amount of resources in the back end. So a couple of examples of some of the heavy operations in our systems are the upload of a VApp template into the cloud. This is going to take HTTP bandwidth. It's going to take a considerable amount of time as all the data kind of chunks in, and then we copy it over to storage. Another example of a heavy operation is the VM cloning operation, which is what happens when you actually copy from the template and create a running VApp. So again, we have to go and copy all that data over, create a separate copy of that data, provision it, potentially run sysprep, so on and so forth, right? So for each of these operations, you can specify how many of these operations can actually happen in parallel in the organization. And these are settings that can be set by the system administrator or the org administrator, and the system administrator kind of overrides the org administrator. Another area that we actually spent a lot of time investing in is kind of thinking about all the data that actually is required to configure and control the vCloud Director powered cloud. So for example, access to the UI, access to the API are all protected by HTTPS. We obviously we have a secure deployment guide that I'll spend some time talking about, where we talk about where you terminate those SSL connections, how you offload those SSL connections, and so on and so forth. Another area that we were concerned about is basically the actual deployment of a VApp template. So when you actually go to deploy a VApp template, the OVF format or the open virtualization format that we use is actually pretty open, by definition. What that means is you can have scripts embedded in it. You can have pointers to hard drives that might actually fall outside the boundary of the OVF that you specify. And this can cause sort of disruption at the back end by causing crashes on the ESX servers that you go to deploy this OVF on. Essentially, the point that we're concerned about is that we do not know where this OVF is coming from, and we're about to deploy it on our infrastructure. So one of the things that we do to establish trust is we actually check the OVF. We actually have about 16 or 17 different checks that we run against the OVF to ensure that when we actually deploy the OVF, it will deploy successfully and not result in a crash in the back end. Now, the upshot of that is that we actually have a point to insert tools, if you wanted to actually examine the OVF for any sort of malware or virus, we actually do have a framework in place to do that. In version 1 of the product, this is not something that's exposed to the end user, but you can script it if you want on kind of the cell. There will be KB articles that talk about that. In future versions of the product, we're going to make this functionality more front and central because we want this is untrusted content that's coming into your infrastructure. Before you actually deploy it, there is potentially any amount of policy checks that you might want to do on it. So we want to give you the ability to actually query those OVFs and have some confidence in what you're about to deploy. Lastly, this is a small, just kind of one small bullet in the slide, but anybody who does compliance will tell you that this is probably one of the most trickiest problems to try to get right. So we do extensive logging in our product. And there are multiple different logs that are created from an end-user perspective, from the perspective of the web server that we're running, from the VC perspective. And we give you the ability to put all those logs in syslog. And you will also see integration with kind of compliance dashboards and other kind of tools that will kind of become available to actually allow you to prove compliance or to generate audit trails for your purposes. Let's see. So no discussion on the cloud is going to be complete without talking about multi-tenancy. When I go and talk to customers, this is probably the number one concern that I get from them. So what I kind of wanted to do in this section is lay out how I think you can set up a multi-tenant cloud. Now, I think it's important to understand that VCD is an infrastructure tool. What that means is that when you set up a VCD-powered cloud, there are lots of decisions that you have to make about how you actually deploy this product. Those decisions will actually decide whether the cloud that you end up with is multi-tenant capable or not. To me, multi-tenancy implies that I can have VMs from two different organizations running, and I do not have to be worried that one of them will be able to either read any data or impact the execution of the other VM. There are several different aspects to this. So I think that for true multi-tenancy, you need to make sure that your data is secure at rest and in motion. Which means that the networks are isolated from each other. You want to make sure that when VMs are running, a particular VM cannot look into the memory state of another VM or cannot access the hard disk of another VM. And I'll spend some time talking about how we think that's possible. So again, to have true multi-tenancy, you have to address not just isolation, but ensure that you have diverse service levels, that your chargeback data is safe, your resource management is fair. All those things combined is kind of what gives you a multi-tenant solution. This is a pretty kind of heavy, text-heavy slide, but let me try to walk you through the way that I at least think about this. So the first thing to note is that the vCloud Director product is an abstraction that's built on top of vSphere. So from the end user of the vCloud Director, he never sees the actual physical manifestation of hosts, data stores, or network that he's actually using. So as the end user, I don't actually know what ESX host my VM is actually running on. All I know is that I have a certain pool of capacity, and up to the size of that pool, I can go ahead and deploy VMs. This, while in itself is not kind of a guarantee of multi-tenancy, it does provide a level of security in the sense that users do not actually see the infrastructure that they are running on. This is essentially a very kind of purposeful by design decision that we've taken. The next thing over there is basically the fact that we leverage vSphere very heavily. So vSphere is the platform that we use to provide multi-tenancy at the hypervisor layer. So once I'm running two different VMs, the responsibility of making sure that those VMs don't interfere with each other, that's actually up to the hypervisor. And this is kind of where there's a lot of history in the hypervisor in terms of the feature set that's built in. So when you actually run VMs on a hypervisor, each VM is a set of VMDKs files. And each VM only sees its own VMDKs. So you do not have a situation where one VM can look into the hard disk of another VM because they're not even aware of the fact that there's actually another kind of VMDK file sitting over there. It's the hypervisor's responsibility to make sure that all memory access actually goes through the hypervisor, and hence you never have a situation where one VM can kind of look at the memory state or the hard disk state of another VM. Now, obviously, it's software, so it has bugs in it. but you have to, like, these would be considered like, Sev0 bugs that would get fixed by the hypervisor team in like hours or days. The second thing is that the hypervisor code has actually been through extensive penetration testing and certification by the NSA, by like various organizations in various countries who've kind of certified it and made sure that it does what it claims it does, right? So I mean, there's a certain level of confidence that you can have given the environments that this code is actually deployed in and the amount of testing that it's been through. Another sort of unique feature about the ESX hypervisor is that it's purpose-built for virtualization. So it's a very thin hypervisor, which means it has limited attack surface, less code, less attack surface. And the idea is that it's specifically written to support pure virtualization and does not have any additional functionality built into it. So, and lastly, the third kind of building block of this multi-tenancy is what I'm calling virtualized isolated networking. That is basically the idea that you have these networks that you can protect using these edge virtual appliances, so you can kind of segment the traffic off from each other. Now, one important thing to note, though, is that this is the one place where you kind of want to make sure that if you have a multi-tenant cloud, that is something that your operator supports. So when you actually go and deploy these networks, if those two networks happen to map to the same trunk port on the port group, well, then at that point in time, the traffic is going to go on the same physical wire. So, if you are looking for multi-tenancy and you expect that multi-tenancy to carry all the way through to the switch, then you have to ensure that the switches are set up so that those trunks are either isolated or have VLAN tags or something associated with them that prevents traffic from two different organizations from landing on that same physical wire. There are some features that we provide in this product that will make isolation at the networking layer a little easier. So two of the things that I'll call out is when you actually go to deploy a vApp, you get to choose whether you want to deploy it fenced or unfenced. The best and the easiest way to think about fencing is it's like wrapping your app in a bubble and ensuring that all the traffic stays inside the bubble. So, you can deploy isolated apps such that the traffic stays within the app. Very useful in kind of test dev scenarios if you just want to test whether, a quick change that you're about to make to the code is going to work. The other thing that you can do is actually use something that we call VCNI or vCloud Network Isolation. These are sort of isolated networks that you can create almost seemingly out of thin air in the back end and connect to like different vApps that are running. So any traffic that goes on these networks will remain isolated to that particular network. Any questions on this?
Yes.
Please, go ahead.
I'm very curious certification. So it's in progress for 4.0, and we've made some significant changes with 4.1 release. So that's going to go back through the mill again?
So, if you know how these certifications work, it's 12 to 18 months. Each release has to go through this again. So, you change one line of code from 4.0 to 4.1, guess what? It's going to be another year before that gets certified. So right now, actually, since I've written these slides, I believe 4.1 has started its certification process as well. I also kind of wanted to call out, in case there is any confusion, that EAL certification is for vSphere and not for vCloud Director. So, this particular product, as of right now, is not planning to go through common criteria. Well, if we get a lot of requests from the federal customers, we will submit it. But right now, we're not in the common criteria right now. And just for VCD, yes. Yes. Yep. So again, just to kind of, recap, since this is something that I want to make sure people get, hypervisor is what ensures the data at rest is isolated. Based on the VMFS file systems and VMDKs, no VMs can look into the memory state or the hard disk state of any other VM, all enforced by the hypervisor. VApps see only direct attached storage, basically virtual hard disks. They do not have any access to the actual underlying file system. And in fact, in our secure deployment guide, we actually recommend that VMs be networked in a way that they can never actually get to the back-end data stores. The ESX host should be able to talk to the back-end data stores, but the VMs that are actually running do not need any access to the back-end data stores. The part that VCD builds that provides this sort of multi-tenancy is the fully multi-tenant cloud middleware layer. So what we do is we maintain this notion of organizations whenever a user goes to take a particular operation, we ensure that they have the right role and they're about to make an operation on an object that they have access to. So nobody in Coke's organization will ever have any access to anything in Pepsi's organization. That is, it is absolutely hard bounded by the wall of by the organization boundary. And in fact, in our UI, those two organizations are actually separate URLs. So they have completely isolated identity systems powering them. And so there is no bleed over between the users between the two groups. Question? Okay, so can you give me an example of what kind of communication? Okay. Okay, okay. Okay. So it's not even so much as if you wanted to connect two different vCenters, say one in San Francisco, one in New York, and talk to them using one sort of vCloud director overlaid on top of that, right? The latency on the link is an issue, right? I mean, in this particular version, at least all our testing has kind of been within one site. So we do not have, once you have two different sites that have a lot of network latency between them, basically the system, you might see the system kind of go out of sync with each other. You might not be able to communicate with some of your ESX hosts on time. We've kind of designed in this particular version of the product for it to be kind of one site, or at least within a certain kind of boundary of network latency. That said, there is absolutely nothing that prevents you from doing this, and we don't believe the system won't work. We just haven't explicitly tested for it. You would see, if you had a server in San Francisco and a server in New York, and you're running traffic over the two, you will see the network latency that path introduces. So your app might be slow, you might see timeouts at your application level. From our perspective, it's just a layer 3 connection, and we'll respect it, right? Okay. I think now I understand the question a little bit better. So a couple of things that I'll say. In V1 of the product, when you create an organization, the maximum size of that organization's virtual data center, or org VDC as we call it, is one cluster. So one organization can have two different virtual data centers. So you can have a virtual data center that is on the East Coast, one on the West Coast. However, you won't have layer 2 connectivity between them. So the only connectivity that you could be able to pull between those two would be a layer 3 connection. So you could use HTTP or something like that, but you will not see a layer 2 network stretched across those two. Does that answer your question? Okay, well, I'll be available. So, let's come back offline and we can probably chat about this a little bit. But I think there are some limitations to how you would be able to implement that scenario in this particular release. So again, we ensure that all our operations are kind of bounded between the walls of that particular organization. You cannot go and access resources in any other organization. And then there are a couple of features that we have that help you sort of limit the damage that one particular VM could do. So vSphere does support shares and limits, if that is one way to ensure fairness of allocation of resources. The second thing I'll call out is that when you actually go ahead and provision VMs, you can specify the reservation and allocation on an org by org basis. So this is kind of how you can control, like a fair scheduling of resources across the different organizations. We have several knobs that organizations can control, that admins can use to control how resources are allocated. So for example, by deciding the level of overcommit, there's an implicit sort of SLA that's enforced in terms of how those physical resources are guaranteed. Another kind of feature that you have is quotas and limits. So you can set quotas for each users, how many VMs they can deploy, how many vApps they can deploy, and so you can control the amount of resources that any particular user can consume. So this slide is basically just kind of a summary of how we build that up over the different layers. Hopefully, I think we've made this clear. This is kind of one of the core kind of ideas that I wanted to get across in this talk. So now we're going to talk about secure deployment considerations, and we have this kind of eye chart that I've kind of put together just to give you guys a little test, right? Just want to call out a couple of different things that I think are worth calling out. So there's two charts over here. This is the logical structure of a real deployment, and this is the actual physical structure of the deployment. Things that I want to call out, so this management pod is what is running VCD, vSphere, the Oracle database that actually powers this product, the NFS for the NFS storage for the vApps that are uploaded. Basically, everything that you can consider to be the control plane is sitting on this management pod. These two clusters over here represent ESX hosts that are actually going to run the vApps or the VMs that customers are going to provision. This is the storage for all the VMs and vApps, and then I've shown some backup services as examples and kind of the secure deployment guide. This is the access to, this is where basically the users would come in to access the GUI backend, and this is kind of the egress route for all the traffic that is coming out of those VMs and vApps that are running in the cloud. So I'm going to use this particular diagram because I think this is actually closer to reality, kind of maps to what's going on. The only kind of major differences over here is I've broken that kind of big honking cluster down to its individual parts, which is a set of vCloud Director cells, NFS storage, and Oracle database. And basically over here, instead of a cluster, you're seeing all the different ESX hosts that are actually running. So what are some of the key things that you want to be aware of when you're actually going to deploy the system? First and foremost, and if anyone over here works in the security space, hopefully some of this is relatively well understood, you want to segment all your different networks from each other. So you want your management plane to be completely separate from your data plane. You want your Oracle database to be on a separate subnet. You want your NFS storage to be on a separate subnet. You want your SAN storage to be its own separate subnet. The more you can segment kind of your individual components and provide firewall rules to access them, the more you can control access, the better auditing you can set up in that particular environment. The second thing I want to call out is that the vCloud Director backend should be a demilitarized environment. So what that means, the front end of these servers have access to the public internet. The back end of these servers are completely hidden away from the public internet, have firewall rules set up to block traffic from leaking out across them. We do recommend that you set these up behind a load balancer, and we also recommend that you deploy a web application firewall. When you deploy the web application firewall, you want to set up your web application firewall so that it can actually inspect the traffic that's coming through it, detect malicious payloads, and probably raise some kind of alarm when it does that. That means that you would probably have to terminate the SSL connections at the firewall and set up a different connection to talk to the backend. In our UI, basically we have this concept. So both the API and the UI have an admin portion and an end user portion. A kind of defense in depth mechanism that we do recommend that you can follow is to actually control who has access to the administrative portions of the API and UI. So a VPN might be one way of ensuring that only certain users have access to the admin portion of the API or UI. Another thing that I kind of want to call out is, so we spoke about those LDAP servers, basically setting up Active Directory or Open LDAP as kind of the backend that's providing the identity for the users that are logging into our database. The way we suggest you set this up is by setting up an LDAP proxy in the DMZ on the enterprise side and allowing these vCloud Director services to talk to those to that backend LDAP server through a proxy. And then, setting up your when you set up the storage network, we don't think the VMs that are actually running need any access to that storage. So set it up on a separate network firewall. It's only the ESX hosts have access to that, to those servers, and you can kind of control what's going on in that backend. Those are kind of the main things that I wanted to call out. Other kind of common gotchas that I've seen, setting up rules around password complexity. There's about 8 or 9 different systems that you're setting up to power the cloud. There's ESX hosts, there's vCenters, there's Linux machines that are running the vCloud Director code. There's an Oracle database. Like lots of different systems. Each of them have different rules for passwords. Figuring out how to set those up through some kind of directory service, enforcing password complexity rules, ensuring each of those maintains the right patch level. I mean, each of these is kind of a pretty big task on its own. But those are the sorts of things you have to watch out for if you're about to deploy a cloud and you're interested in deploying a high security cloud. Sure, please.
In the lower right-hand corner, isolated encrypted storage, is that being achieved through third party, or is that something that's now being built in?
No, this would, so we, in sort of the deployment guide, we recommend that if you're interested in protecting the contents of that storage, you encrypt it, but we are not shipping any of that storage back, and it would just be a choice that you make. Yeah. So kind of just to touch on some of the key points before we kind of close out, the capabilities and features of this particular release of the product. It builds on top of vSphere capabilities and scales up to about 25 different vCenters. Allows you to create what we're calling virtual data centers by pooling resources from vSphere. Once you've created those pools, you can go ahead and chunk them out for end user organizations. We provide end user self-service, and we have this concept of a service catalog, which you can use to deploy vApps or VMs. And then we provide tight integration with chargeback so that you can run reports and show what it actually costs to run these resources. What we actually hope to unleash using this feature set, basically we want users to stop thinking about how they're producing IT resources and think about how they're being consumed by the business. So get IT out of the business of running large complicated data centers, simplify as much of that and free up their time to actually go and innovate. So better business agility is the ultimate goal of that. We want to do this in a way that end users feel like they have control over their infrastructure. So security and multi-tenancy are core kind of design principles of the stack. We want to reduce the cost that it takes to actually maintain your IT infrastructure. So by doing this massive pooling of resources and kind of allowing you to run resources in a virtualized manner, we think that you can actually reduce the cost it takes to power your infrastructure. And then lastly, we're doing this in a way that allows you to leverage your existing investments. So, whatever servers you have running vSphere, whatever kind of, your existing x86 infrastructure can be reused and doesn't have to be redesigned. The same is true of the apps. The way we've designed the system, you can take your existing workloads and upload them into the cloud. You also have the option of rewriting workloads specifically for the cloud, but we do support any existing workload. And then lastly, these are all the talks that are related to the vCloud Director product line. We're at Wednesday, so these are all the ones that you have to attend. You don't have to worry about all of those, right? I encourage everyone who hasn't done so to go and try the hands-on lab. The product is installable and runnable in the lab. I think it's a great kind of way to get your hands dirty and see what's going on. I'll be available for questions after this. If you have any questions, feel free to come up. And with that, if there are any questions, please go ahead and let me know. Oh, by the way, one last thing. I think it's on this slide. Do please fill out the survey that is available. If you're interested in providing any feedback, we do appreciate it.